In this video, we are going to watch Unit 5 of Human Values and Ethics. Scientific ethics, also known as research ethics or scientific integrity, refers to the moral principles, standards, and guidelines that govern the conduct of scientific research, experimentation, and dissemination of findings. Honesty and integrity. Scientists are expected to uphold honesty and integrity. This includes accurately reporting the data, methods, and results without manipulation, fabrication, or falsification. Objectivity. Objectivity is essential in scientific inquiry to minimize the bias subjective influence. Scientists should approach research inquiries with impartiality, open mindedness, allowing evidence to guide their conclusions rather than preconceived beliefs or agendas. Transparency and reproducibility. Transparency involves making research method, data, and findings openly accessible to the scientific community and the public. Responsible conduct. Responsible conduct encompasses ethical behavior in all aspects of scientific research, including interactions with colleagues, research participation, and a broader community. Respect for participants. Researchers have a duty to respect the dignity, autonomy, and rights of individuals participating in research studies. Peer review and collaboration. Peer review is an essential component of scientific ethics, involving the evaluation of research manuscripts by independent experts prior to publication. Peer review also helps ensure the quality, validity, and reliability of scientific findings and provides constructive feedback to authors. Continuing education and professional development. Scientists should engage in lifelong learning and professional development to stay informed about the ethical standards and emerging technologies and best practices in their field. Transparency in scientific pursuits. Research transparency promotes the values of openness and transparency in the scientific process. It is an ethical approach to research which improves research integrity and enhances the informational value and impact of research. Research transparency includes registering the studies, sharing study data, and publicly reporting research findings. Researchers are encouraged to adopt transparent and responsible practices to improve research integrity and trustworthiness of scientific findings. Research transparency benefits everyone, including researchers, governments, healthcare providers, and members of the public. It is therefore important in publicly funded research, becoming an increasingly significant requirement from, from any journals, institutions, and funders. Transparency includes the clear, detailed, and explicit documentation of all stages of research process. This allows other researchers to understand, evaluate, transfer, and build upon the study. Important aspects of transparency in qualitative research: methodological transparency, analytical transparency, and reflexive transparency. Let's see about all the three transparency one by one. Methodological transparency involves providing a comprehensive description of research methods and procedures used in the study. This includes detailing the research designs, sampling the strategy, data collection methods, and ethical considerations. Analytical transparency, it refers to the clear and detailed documentation of the data analysis process. Reflexive transparency involves the researcher reflecting on and disclosing their own role in research, including their potential biases, assumptions, and influences. Benefits of research transparency includes enhances research integrity and credibility, produces research which is responsible, reproducible, open, and evidence-based, facilitates proper interpretation of results, promotes the open dissemination of research and equitable access to scientific knowledge. Researchers and other stakeholders can identify opportunities to collaborate and improves reproducibility and validity of findings. Now, let's look at the strategies for achieving transparency in research. Clear research objectives and methods. Transparency begins with clear and explicit statement of research objectives and questions. Researchers should be able to explain why they are conducting the study, what they hope to learn, and how they are planning to achieve their objectives. Second, thorough documentation and analysis. In the data collection phase, a researcher should provide thorough documentation, including original data records such as transcripts, field notes, or images. Third, reflexivity and acknowledgement of bias. Transparent research involves a process of reflexivity where researchers critically reflect on their own role in the research process. Fourth, conflict of interest disclosure. Researchers should disclose any potential conflicts of interest, financial or otherwise, that could influence their work or the interpretation of results. Transparency regarding affiliations, funding sources, and competing interest helps maintain credibility and trust in the scientific research. Fifth, transparent reporting and publishing. Transparency also involves the open sharing of research materials and data where ethical and legal guidelines permit. This may include providing access to interview guides, survey instruments, data analysis scripts, raw data, and other research materials. Open sharing allows others to scrutinize, transfer, or extend the research, thereby enhancing the transparency and trustworthiness. The reporting and publishing phase should adhere to the principles of transparency. Fairness in scientific pursuits. It is important that experiments conducted in science are fair in order to ensure the reliability and accuracy of the results. Scientists may perform the tests or experimental inquiries to find out the answers. Conducting a fair test is most important ingredient of doing good, scientifically valuable experimentation. A fair test is an investigation where one variable is changed and other conditions are kept same, which what is measured or observed is referred to as the dependent variable. Here are some ways how fairness in experimentation is crucial. First, validity of results. Fair experiments help to ensure that the outcomes are truly reflective of the variables being tested. If the experiment is not fair, it can introduce bias and lead to inaccurate conclusions. Second, reproducibility. Fair experiments can be replicated by other researchers and yield consistent results. This is a fundamental aspect of scientific method as it allows for independent verification of findings. Third, credibility. Fairness enhances the credibility of the research. If an experiment is perceived as biased or unfair, it can undermine. Sorry. Fairness in scientific pursuits. It is important that experiments conducted in science are fair in order to ensure the reliability and accuracy of the results. Scientists perform the tests or experimental inquiry to try to find out the answers. Conducting a fair test is one of the most important ingredients of doing good, scientifically valuable experiments. Here are some ways why, uh, why fairness is important in experiments. First, validity of results. Fair experiments help to ensure that the outcomes are truly reflective of the variables being tested. If the experiment is not fair, it can introduce the bias and lead to inaccurate conclusion. Second, reproducibility. Fair experiments can be replicated by other researchers and yield consistent results. This is a fundamental aspect of the scientific method as it allows for independent verification of results. Credibility. Fairness enhances the credibility of the research. If an experiment is perceived as biased or unfair, it can undermine the trustworthiness of the research and its findings. Fourth, ethical considerations. Fair experiments are designed to minimize harm to participants, subjects, or the environment. Ethical concerns are taken into account to ensure that experiments are conducted responsibly and respectfully. Elimination of confounding factors. Fair experiments control for variables other than the ones being tested. This helps in isolating the effect of the independent variable on the dependent variable and reduces the chances of incorrect attributions. Generalizability. Fair experiments increase the likelihood that the results can be generated to a longer population or a broader context. This allows for broader application of findings. 7. Advancement of knowledge. Fair experiments contribute to the cumulative body of scientific knowledge. Rigorous and unbiased research builds a strong foundation for new discoveries and breakthroughs. Significance of fairness in scientific research. Equal opportunity. Ensuring equitable access to resources, opportunities, and authorship regardless of factors such as race, gender, or institutional affiliation promotes fairness in scientific collaborations. Peer review process. Implementing rigorous, unbiased peer review process helps ensure that research publications are evaluated based on scientific merit rather than personal biases. Ethical standards. Adhering to ethical guidelines and standards such as those outlined in institutional review boards for human subjects or animal care committees for animal studies ensures fairness in research involving human participants or animals. Data handling and reporting. Handling data, responsibility, and reporting the findings accurately without manipulation or selective reporting ensures fairness and trustworthiness in scientific communication. Scientific inventions for the betterment of society. Science has a specific role as well as variety of functions for the benefit of the society, creating new knowledge, improving education, and increasing the quality of our lives. Science must respond to societal needs and global challenges. Science is essential for the development of human society for a variety of purposes. The application of scientific knowledge to modify the policies at national and international levels has benefited many communities and population by providing equal access to resources. Scientific knowledge allows us to develop new technologies, solve practical problems, and make informed decisions both individually and collectively. It contributes to ensuring a longer and healthier life, monitors our health, provides medicine to cure diseases, relieves aches and pains, helps us to provide water for our basic needs, including food, provides energy, and makes life more fun, including sports, music, and entertainment. Few notable inventions include vaccines. Inventions like the smallpox vaccine by Edward Jenner and vaccines against diseases like polio and measles have saved countless lives, reduced disease burden, and contributed to the near eradication of certain diseases. Antibiotics. The discovery of antibiotics, such as penicillin by Alexander Fleming, revolutionized the medical field by treating bacterial infections effectively, thereby reducing mortality rates, and improving public health. The light bulb. Thomas Edison's invention of the practical incandescent light lamp in 1879 brought artificial light to households, business, and public spaces. Electricity. The harnessing of electricity by inventors like Thomas Edison and Nikola Tesla enabled the development of lighting, heating, transportation systems, and modern communication networks. Medical imaging. Technologies like X rays, MRIs, and CT scans have revolutionized the medical diagnosis, enabling early detection of diseases and improving treatment. Computer and Internet. The invention of computer and discovery of Internet has revolutionized communication, access to information, education, commerce, and social interactions on a global scale. Telecommunication. Inventions like the telephone, mobile phones, and satellite communication have connected people globally, facilitating rapid exchange of information, emergency response coordination, and economical development. Personal computing. The development of personal computers and smartphones have democratized access to computing power, information, and digital services, transforming education, work, productivity, and entertainment. Unfair application of scientific inventions. Humans rely so much on technology that their physical health is affected. Science and development have very adverse impact on nature, including the exploitation of natural resources and leading to deforestation. Human use technology as a weapon for illegal activities. Some disadvantages of scientific advancements to society are increase in carbon dioxide emission, increase of hazardous waste, increased urbanization, and increase in resource use and pollution. Unfair scientific advancements in the society include weaponization and warfare, surveillance and privacy, biased algorithms and artificial intelligence, arms and conflicts, security risks, biological and chemical weapons, unintended consequences, and environmental impact. Now, let's look at the role and responsibilities of scientists in the modern society. Scientists play an important role in educating the non scientists about the context and process of science. In fulfilling these responsibilities, scientists must take the time to relate scientific knowledge to society in such a way that members of the public can make an informed decision about the relevance of research. Now, let's look at the rights of all scientists. First, conduct of science. The right conduct of research on many topics that does not breach professional ethical standards. The right to oppose unethical or illegal actions, policies, procedures, or other directives that impact the conduct and publication of service without fear of retaliation. The right to be clearly informed about requirements and expectations of employment. The right of due process related to any complaint of scientific misconduct, including the rights to view, review, and inspect evidence, have legal representation, provide a defense in hearing before peers and appeal. Second, collaboration with others. The right to work with and mentor colleagues of choice, independent of politics or affiliation. The right to decide jointly how researchers can undertake and share, adhering to ethical scientific principles and respecting intellectual property. Third, communication. The right to freely express results of research at scientific meetings, in a scientific literature, and in media without impediment, harassment, threat, or retaliation. The right to protect preliminary results until publication. The responsibilities of scientists include excellence in the conduct of research, ethics, and inclusion. Excellence in the conduct of research employ high quality research methods to the best of one's understanding and ability and base conclusions on critical analysis of all of the evidence. Ethics communicate facts, conclusions, and uncertainty honestly, clearly, and transparently, and disclose all the conflicts of interest from any sources that would be perceived. Inclusion raise a diverse workforce and inclusive environment that allows science and scientific careers to develop. Thank you.